Have you ever seen iron rusting, pipes leaking, or ships getting eaten away by seawater? That's corrosion at work, silently destroying metals worth billions every year. But here's the thing. Corrosion is not just rust. It comes in many surprising forms. Today, we'll explore the major types of corrosion with real-world examples, diagrams, and easy explanations. So let's dive in before corrosion eats up our time. First things first, what exactly is corrosion? Corrosion is the gradual destruction of metals by chemical or electrochemical reaction with the environment. In simple words, it's when metals return back to their natural ore state. Types of corrosion. This is the most common type, also called general corrosion. The entire surface of the metal corrodes evenly. For example, rusting of an iron sheet left in open air. Galvanic corrosion. Ever seen what happens when two different metals are connected in water? The more reactive one corrodes faster. That's galvanic corrosion. For instance, when steel and copper are joined in a pipeline, steel will corrode first. Another example, zinc electroplated on the steel is anodic to steel, corrodes first and protect steel in another case. Tin plate electrodepositing on steel sheet act as cathodic to steel in presence of oxygen, and in absence of oxygen, it act as anodic to steel. Pitting corrosion. This one is dangerous because it creates small pits or holes in the metal surface, often leading to leaks in pipelines and tanks. The scary part? It's hard to detect until it's too late. The pits generally develop in the direction of gravity. Structural heterogeneities and compositional heterogeneities on metal surfaces are common places where pits initiate. Crevice corrosion. When corrosion hides in tight gaps, like under gaskets, bolts, or joints, we call it crevice corrosion. The trapped moisture and oxygen deficiency make these spots perfect for localized attack. Crevice corrosion occurs in many alloy systems such as stainless steel, copper alloys. For getting crevice corrosion to occur, a crevice must be wide enough to let the liquid enter and narrow enough to get liquid stagnant. Intergranular corrosion. This type attacks the grain boundaries of metals, especially in stainless steel if not heat-treated properly. Imagine the metal crumbling from inside while the surface still looks fine. Example. Intergranular corrosion occurs in austenitic stainless steel that are heated into or slowly cooled through the 500 to 800 degrees centigrade comma. Chromium carbides can precipitate at the grain boundary interface. When chromium carbides form at the grain boundaries, they deplete the regions adjacent to the boundaries of chromium, so that the chromium level in these areas decreases below 12% chromium level, then exposed to corrosive environment.
Stress corrosion cracking, SCC. Now imagine a metal under constant stress in a corrosive environment. It can suddenly crack without warning. That's stress corrosion cracking, a common enemy for chemical plants and aircraft parts. The unequal cooling rates, poor mechanical design for stress, phase transformation during heat treatment, cold working and welding may cause stress corrosion cracking, SCC. Example, stainless steel cracks in chloride environment, but not in ammonia environment. Erosion corrosion. When fast-flowing liquids or gases hit metal surfaces, they wear away the protective layer and cause erosion corrosion. Think of turbine blades, pumps, and ship propellers. Another example, and slurry containing silica and other abrasive materials passing through mild steel pipes remove rusted surface and permitted dissolved oxygen to enhance corrosion on surface. Microbiologically influenced corrosion, MIC. Yes, even tiny microorganisms can cause corrosion. Certain bacteria create acidic byproducts that eat away metals. This is common in oil pipelines and water systems. So, the main types of corrosion are uniform corrosion, galvanic corrosion, pitting corrosion, crevice corrosion, intergranular corrosion, stress corrosion, cracking, erosion corrosion. Microbiologically influenced corrosion, MIC. The good news, corrosion can be controlled. Some methods include applying protective coatings like paint or galvanization, using corrosion inhibitors, cathodic protection like sacrificial anodes in ships. Choosing the right alloys for the environment. Corrosion may be a silent destroyer, but with the right knowledge, we can fight it. Which type of corrosion have you seen most often? Rusting cars, leaking pipes, or maybe something else? Tell me in the comments below. And if you found this video helpful, don't forget to hit like, subscribe, and share it with your friends. Let's spread knowledge faster than corrosion spreads on metal.